Very good morning to one and all. Today we are going to see about the load curves, load duration curves, etc. We are going to see. So, firstly, load curves. What is the major role of this load curves? The curve showing the variation of the load on the power station with respect to time is known as the load curve. So, if you take a power station, how the load will be varying with respect to time. Say, for example, 24 hours of 24 hours in a day we have taken. So, how the variation will be and what time, how the load will be varying like that, we can easily know. In a substation also, they might be having this daily load curve. They will be plotting this daily load curve, how the load is varying. Even in the generating station also, they will plot what is the amount of power we generated, so that it can meet the demand. Like that, they may plot. So this is a simple curve showing the variation of the load with respect to the time. Okay. So if you see here, this is the one example of a load curve, wherein which this axis is taken as load in megawatt. This axis is taken as load in time in hours. Time in hours. So here from 12 midnight to again 12 midnight, the whole one day it was taken. So two axis, two hours it was taken. Like 12 midnight to 2 a.m., then 4 a.m., 6 a.m., 8 a.m., 10 a.m., next 12 noon, 2 p.m., 4 p.m., 6 p.m., 8 p.m., then 10 p.m., and again 12 midnight. So for a whole day, it is plotted. Say this is a substation. Substation, this load is in megawatt. So what is the so initially, if you see, like from 12 midnight, the load is somewhat less, around 1.1, like that, 1.1 megawatt. Like that, slowly it is increasing at a time of 4, and again slowly it is increasing. So at 6 o'clock, I think 6 o'clock, majority of the people, like if you say the particular power station is connected at a domestic loads, whereas industrial supply is somewhat less. So at 6 o'clock, majority of the people can use their appliances in the mode. So from the 6 o'clock, like average at the 7 o'clock to this 9 o'clock. 9 o'clock will be the peak time. Okay, 7 o'clock to 8:30. So here in this graph, around 8:30, the load is going to peak, and again it is coming down. So, again, it is coming down. At 10 o'clock, it is coming down. From 10 o'clock to this 12 o'clock, 12 and this 2 o'clock, that is the peak time for your industrial loads or commercial loads. The commercial loads, they are starting. After this, domestic loads are less. So, commercial loads are starting, okay, so that it is increasing like this, because domestic loads are very less, only industrial loads. And the industrial loads, slowly it is moving like this. After 2 o'clock, so there is a small dip in the load. And again if you take, like after 4 o'clock, there is a peak. After 4 o'clock, there is a peak for 4:30, 5 o'clock. So majority of the people, they will come back to their homes. So they will start using their own appliances. After that, the this load may be increasing up to 6 megawatt. 6 megawatt. So up to from this is the 6 p.m. 6 p.m. it is reaching the maximum load. Why? Because 6 o'clock will switch on all our lights, ceiling fans, appliances, everything will switch on. Then slowly, up to 8 o'clock, slowly it is decreasing. Slowly it is decreasing. After that, slowly In a domestic load, if you take, they will go for the bed after this time, 9 o'clock. So slowly it might be decreasing, and it is coming to like this. Okay, so if you see like industries, they will work in the three shifts. Okay, three shifts, they will start at 8 o'clock, 8 o'clock to morning, or morning 6 o'clock or 5 o'clock. So that is one shift. So from 6 o'clock to 12 o'clock or 1 o'clock, 1 p.m. they will start with another shift. Then 1 p.m. to again um, 8 p.m. again another shift. So three shifts they will work. So this midnight shift, they can able to run their like heavy machineries, midnight 12 midnight to this 6 o'clock, 6 o'clock, and even from here also from 8 o'clock, 9 o'clock they are starting their shift. From 9 o'clock to this 12 midnight, that is they can use their heavy machineries, and so six from morning 7 o'clock, 6 o'clock to this 9 o'clock, they may not be using the heavy machineries, whereas small machineries like that they will go for logistic purpose, they will go for maintenance works in particular this 2 hours. Then after that slowly they will start at 9 o'clock. So 9 o'clock up to 1 o'clock, so there is no lunch hours. So why? Because they are working in shift, so immediately after this 1 o'clock, the second shift people will come. Okay, so similarly they will run up to this 5 o'clock. 5 o'clock they will run. After that, they will not run, they will go for this logistics, so manual works they will do. This hours, they may like as peak hours, 6 o'clock to this 10 o'clock, 10 o'clock, sorry, 9 o'clock. So after that slowly they may start their shift. So even in industries, if you take, like, they have to get the permission, so in which hours they have to operate the machine. From that substation they have to get substation itself will give a chart, based on their loads. They will give a timetable like that, timetable. So in which hours that particular machineries have to operate at. So the machineries, load also they have to give. So this many machineries we are having. So we are consuming the load of this many kilowatt hour. Like that they have to give. So based on their load and based on the incoming and outgoing in the feeder substation. Okay, incoming and outgoing voltage, they may tell and which hours they have to operate like that. So majorly, I said no, in that particular hours only they will go for running that machines, very big machineries. uh, so this is of your load curve. So you can also draw your load curve. So today, a small assignment for you, for everyone. So go to your energy meters. Go to your energy meters. So I think 100 percentage in all our homes we are having the electronic energy meter only. So I think nobody in India is using the old analog energy meters. Majority of the 100 percentage of people, they are using only electronic energy meters. There will be one button will be there. Okay, so you press that button so that you'll get the power factor, you'll get the energy like in kilowatt hour. Then you'll get the current, everything, you voltage, range, everything you can get if you press that button. So hourly once, you need to note down the hourly once load. So you note down, you start from after this class, from 12 noon, or next day from 12 noon to next day 12 noon, like 12 noon you start. So 12 noon, what is the energy, like that you note it down in your paper. Then after that, 1 o'clock, 2 o'clock, 3, 4, like that, 1 hour once you go to your energy meters and you note down that reading, like up to 10 o'clock. I think up to 12 o'clock itself you can plot. Okay, so majority of the people, you're watching IPLs, and you're watching some films, so that up to 12 o'clock you can plot. After that, if possible, you can note down, or otherwise start with like next day is 6 o'clock, like that you can note down. You can easily draw the graph. So 6, 7, 8, 9 up to next day 12 noon. So that after that, what you do is you just plot the load curve. You just plot the load curve in of your particular home. So how the load is varying, how the load is being varied. It will be very very interesting for you, so that you can optimize your like power bill also, like tariff also you can optimize. So which is the peak hour of your home? Like definitely it might be off from 6 o'clock one, from 6 o'clock to 10 o'clock or 9 o'clock will be your peak time in your home. So don't just to be general. Okay, normally how we are using the appliances, like that only you use, and you just note down. So after that you may try to like plot the load, and you can easily know which is the peak, okay, maximum demand, like maximum peak hour in your home. So how it is varying, so what time it is going up in the peak, so that how you can optimize, how many appliances you can know, how many appliances you just on in that particular in your home, so that you can later you can analyze, and you can switch off or switch on, like that you can manage your tariff also, even your tariff also you can note it. And another one thing, if you log into through your like electricity board website, like TSS CDL, so that website, if you log in, you can easily in that also you can get the daily load curve. Sorry, daily load curve, it will not be there. You can get your monthly load curve, and as well as your yearly load curve. So how from 2020 to April 2021, like 2020 April to 2021 April, uh, and that also you can plot. That also you can take that data also. So which month you have used, which month you have
என்னம்மா
used the peak. That also you can,
என்னம்மா
yeah, that also you can see. This is of your load curve. So this load on the power station is never constant. It varies from time to time. Time to time it is varying. So we can't predict that this is the particular load in the particular day. Today's date, this will be the load, like that we can't predict. It might be varying. We can predict approximately, we can predict, and it might be varying. So these variations of the whole day are recorded half hourly or hourly, are plotted against the graph. This curve obtained is known as the daily load curve, and it shows the variation of the load with respect to time during the day. This figure shows the daily load curve of a power station. It is clear that the maximum load on the power stations varying, being that 6 p.m. in the case. So majorly in our home also, maximum load might be of from starting from our approximately 5:30 to this 10 o'clock or 9 o'clock range only. We will be using the maximum loads. You can check also, like it may be seen that the load curve indicates a glance that general character of load that is being imposed on the plant. So from this load curve, what they will do is in substation daily they will plot this load curve. Daily they will plot this load curve, how the load is varying, like that. So today's so 30 days in a month they will plot, and even for 365 days in a year also they will plot. So what is the use of this load curve? So like next year's 2022, on the same day, if they want to generate the power now, what they will do is they will take this load curve. They will take the previous year load curve, and they may analyze how the load is varied during that day. So how the industrial how many industries are connected on that time, like how many domestic loads are there. So this many connections, like 1500 domestic load connection, then there's 10 to 20 industrial connections are there, then commercial tariffs are of again 50, like that. They may analyze. So due to this, this load is varying like that. So in generating station also, how they will generate now based on the previous year load, approximately based on the previous year load, the same day. So how the load might be there. So based on that, they may generate. So they may not generate only exactly this range. Okay, combining all the substation, they may not like go for exact generation. They may go for some 100 megawatt, 200, 500 megawatt extra only. Why? Because the load is increasing, and also they know what is the yesterday's load. Yesterday's load, if they analyze now easily, today load also might be of approximately same. So somewhat it might be varying if the climatic condition is same, like that it is very hot outside, same like that, they will go for the same generation with the extra, somewhat extra they may go for. Otherwise they may generate the same power only. Or in weather forecast they may tell, like today it is going to rain for this many hours, for 5 hours, from evening it may rain na? So they may decrease the load, approximately they may decrease the load in that evening hours. If it rains also, they may decrease. So because appliances will be used, might be somewhat that might be reducing. So from the load dispatch centers, they may tell the generating station to reduce their generation, so that they will reduce the generation of 500 megawatt, 200 megawatt, 100 megawatt from thermal, or from hydro, like that they may decrease. So what is the importance, the daily load, and also there is a monthly load curve is there, as I said. Like daily, what they will do is they will go for them noting down this maximum demand from the power station. So otherwise average demand they will note down. So based on that, they will plot the monthly load curve. So for 30 days, 1 2 3 up to 30 days. So first day, day one, like May month, day one. Day one, what might be the maximum load? 6 megawatt. So day two, 8 megawatt. Day three, 10 megawatt. Day four, 5 megawatt. Like that, they may plot up to 30 days. So by seeing the monthly load curve, they may analyze how in a month how it might be varied, how it might be varied for 30 days. So what is the average power? Average power. What is the peak day of that particular month? Which in which day it has reached the maximum? So on which day it is very average? On which day it is very very low? The demand is very very low. Like that, they may analyze. So even in yearly also same like that, from 1 to 365 days, 1 to 365 days. Previously they might be plotting in a graph plot, like that. So nowadays, due to the technological development, so even in Microsoft Excel also you can easily plot. In Word also you can, Microsoft Word also you can easily plot. Like if they give the data 1 to 365 days load, easily in a second, it will plot. It will plot and it will be showing. And there are many softwares also. Even in MATLAB also you can do. There are many softwares also to analyze this particular load curve. So easily in a year they can analyze. And even for like next year, if they want to generate also, they have to simply see that that particular day. So this hundredth day. Hundredth day, what is the maximum demand? So hundredth day, this is the demand. So that the same hundredth day, they may generate the same to that, but somewhat the load that like generation might be added over that. And also, what is the importance? This curve shows the variation on the load on the power station during the different hours of the day. So variation of the load in the different hours, this curve we can easily analyze. And the area under load curve gives the number of units generated in a day. So what is the maximum demand is nothing but what is the amount of power generation. So that is somewhat equal. Some losses might be there, but more or less like losses 15 percentage if you minus now, more or less you can easily analyze what is the generation in that particular day. So generation is nothing but the demand, no? So whatever the generating, that is consumed by the load, that is approximately equal to demand plus some losses might be there. Losses also 15 percentage they will add, but that the demand, from the demand we can easily analyze what is the generation in that particular day. Like 15 percentage they have to add, approximately plus or minus 15 percentage or 18 percentage they have to add. That's it. So this gives the unit generated in a day. That is unit generated per day is nothing but area in kilowatt hour under the daily load curve. Next thing is that the highest point on the daily load curve represents the maximum demand on the power station on that particular day. So which represents the maximum demand. So if I want to analyze the maximum demand, I can easily note down this is the maximum demand. So by analyzing the curve. Next is under the area under the daily load curve divided by the total number of hours gives the average load on that particular day. So average load is equal to area in kilowatt hour under the daily load curve divided by 24 hours. Okay, so that is the amount of energy generated in the particular day divided by number of hours in that particular day. 24 hours if we are taking 24 hours. Next, ratio of the area under the load curve to the area of the rectangle which is contain the load factor. So load factor is given by average load divided by the maximum demand. So average load you can easily analyze. Average load divided by maximum demand. What is the average load here? Like that, you can go for all the peak divided by that particular hours will give the average. Then the maximum demand. What is the maximum demand? That easily you can analyze, and you can go for load factor. Load factor. So this load curve helps in selecting the size and number of generating units. Number of so how many generating stations are there? What is the size of that particular generating station? That also you can easily analyze. Next, this load curve helps in preparing the operation schedule of that particular station. So how the we can schedule that based on that load curve, how we can schedule to that particular station, and also to the particular demand. Demand means load. So where we are connected. So how we can operate if some deficit is there. So which feeder we have to open for how many hours, for how many minutes, half an hour. So in summer also we are getting a minimum half an hour. We are getting the deficit. Minimum half an hour they are going, they are cutting the power. In even in afternoon hours or in the noon hours, 12 noon, like that they are cutting for one 15 minutes to half an hour. They are going for some due to the deficit. Next, like duration curve also there. 1 minute, I'm showing. Yeah. So this is the load duration curve. So when the load elements of the load curve are arranged in the descending order magnitudes, then the curve thus obtained is called load duration curve. So like 24 hours we are having the data. Like you have noted down now in your home. tomorrow, today we are you are going to note you are going to note the load, like a kilowatt hour you are going to note down, no? So with that, what you do is, after noting down for approximately 20 hours or 18 hours, so after that, you just go for sorting that in descending order, descending magnitudes of your loads. like uh, this is the load curve. This is the load curve, that load is varying like 12 noon to this is the duration in hours. Okay, so duration means so like uh, 12, this is zero. So zero, one, two, three, four. So how many duration, the load is varying, so 0 to 5 hours the load is 5 megawatt. So 0 to 5 hours, 4 hours. So next 4 to 8 hours the load is 15 megawatt. So next 8 to 16 hours the load is 20 megawatt. So 8 to 16 means 8 hours. So 8 hours duration. So again, 16 to 24, like again 8 hours, 8 hours duration, again 5 megawatt. Like that, the load is varying. This is the load curve. So load duration curve, how to plot is in the sense. So you have to sort this is in descending order. Descending order. So we plotted this load curve now. So what we have to do is, yeah. So we plotted like this, no? So what you have to do is, we have to sort all this in descending order. So say 6 megawatt, like for 6 p.m. And then again, this uh, 5 5.7 megawatt, again in 7 p.m. Like that, you have to plot in descending order. So all in descending order. So after that, you have to plot. You have to plot this curve. Okay, so this load duration curve, from this load duration curve you can easily analyze so how the load is varying. So how, like for example, 20 megawatts is remaining for how many hours, how many duration of the hours that particular power plant is operating for the maximum load. So here, say for example, here 8 hours, 8 hours, that particular substation is maintained for 20 megawatt. Again, so some 8 to 12 hours. So for 4 hours. So duration between this is 4 hours. So here, hours in duration. Duration in hours. This axis is duration in hours. This is in load in megawatt. So you have to very careful while plotting the load curve and load duration curve. Whereas there in load curve, that is hours in, sorry, time in hours, time in hours, or time in a particular month, something like that. But time in, usually if you take 20, like 1 day na, time in hours. So here duration in hours. So this is not time. If you write like time na, this is wrong. Okay, even though all your answer is correct, this is wrong. So this is in duration. So you have to plot not like 12 like that. You have to plot from 0, 1, 2, 3, 4 up to 24 hours. So how the load is varying. So this is duration. So time duration, wherein which the power station is in operation. So like that, you have to go for. This is the load. This is the duration in hours. So it is varying like this. So again, from 12 o'clock to 24 hours. So it is varying like 5 megawatt. 5 megawatt it is varying. So this is of your load duration curve. So what is the following things to be noted down? The load duration curves gives the data in more presentable form. In the other words, it is readily shows the number of hours during which the given load has prevailed. Okay, so it can shows that number of hours during which the given load has utilized. Okay, so in the substation they will plot, they will plot these two curves, that is, one is load curve and as well as the load duration curve. So they will go for plotting the these two curves. Next, the area under the load curve is equal to the corresponding load curve. Obviously, the area under the load curve is in kilowatt hour, which gives the unit generated on that particular day. So this is the unit generated in the substation. They will go for this duration curve so that they can analyze how many duration that say 1000 megawatt here 1000 megawatt is operated for 8 hours. Next, some 500 megawatt is operated for this many 4 hours. Next, again to 200 megawatt is operated for again 8 hours. Like that, they may analyze. So how many hours the particular generators is in operation. So how many megawatt of power, like how many megawatt of generation that is in operation. Like that, easily they may analyze. Next is yeah. Next, the load duration curve can extend to include the any period of time by laying out from 0 hours to 8760 hours. That is for a whole year. Okay, so 365 into 24 if you multiply 8760 hours. So the variation and distribution of demand for the entire year can be summarized in one curve. This curve obtained is known as annual load duration curve. So instead of 24 duration, you can go for 0 to 8760 hours. So if you plot now, easily they can get how the load is varying throughout the year. So by seeing the load duration curve, so in the particular day, so what is the maximum maximum generation also we can analyze. So how it is varying. So like that, they by during seeing the load duration curve, they can generating units. They may generate the particular um, uh, like load or demand that they may generate. Next, these are some of the important terms. So first one is connected load. So what is the connected load? So connected load is nothing but sum of continuous ratings of all the equipments connected to the supply system. So what is meant by a load? A load is nothing but the sum of the continuous rating of all the equipments or appliances which is connected to the particular system. Okay, so how to analyze the connected load of your home? So you have to analyze how many tube lights are there, how many LED lights are there, how many ceiling fans are there, then how many refrigerators are there, washing machines are there. So you need to how many iron boxes there. So you need to take all the watt ratings, like for a bulb, and as well as a ceiling fan, then as well as a washing machine, refrigerator, then iron box. Like that, if you go for adding all the things, you may be getting. So what is the connected load of your particular home? So it is nothing but sum of connected loads of all the consumers connected to the is the connected load to the power station. Like that, in your load, sorry, in your home, it might be of this many kilowatt hour or this many kilowatt, like 500 kilowatt, sorry, 100 kilowatt in a day. So like that, if you go for like a many like a home, which are all the connected in the particular substation, so you can easily calculate. So what is the connected load? What is the connected load approximately? Like that is the of whole as a whole. That is the connected load. So the load may be varying by time to time. Okay, you can on you can't on all these appliances in all the hours, like in that particular time only you can on and you can use that appliances. Washing machine means particularly it will work for half an hour or 1 hour, like that. Then a refrigerator 24 hours it is working. Like that, appliances it may be changing. Iron box means like 15 minutes to half an hour. Like that, it may be running. So next is this of connected load. Next is maximum demand. So how to analyze the maximum demand? It is the greatest demand of the load on the power station during a given period. So it is the greatest demand of in a power station during a given period of time. So in a period of time we have taken as 24 hours. So it is the greatest demand on the particular duration. For the particular duration, what is the greatest demand here? It is 6 megawatt. So this is the maximum demand. Like that, you have to analyze what is the maximum demand of your particular your house also. Next, the load on the power station varies from time to time. The maximum of all the demands that is occurred during a given period is the maximum demand. That is shown in the figure. That is 6 megawatt at 6 p.m. So that is of 6 p.m. The maximum demand is generally less than the connected load because all the consumers do not switch on their connected load to the system at a time, as I said, no. So all will not switch off all the loads at a particular time. So it may be varying. They may not switch on or switch off at a particular time. The knowledge of maximum demand is very important as it helps in determining the installed capacity of the station. So it will this maximum demand helps in determining the installed capacity. How much we have to on, how much megawatt we have to on, like how much megawatt we have to generate, like that we can easily tell by seeing the maximum demand only. Then the station must be capable of meeting the maximum demand. So next, coming to the demand factor. What is demand factor? Demand factor is nothing but ratio of the maximum demand on the power station to its connected load. That is, demand factor is equal to maximum demand divided by the connected load. That is, ratio of the maximum demand divided by the connected load. So demand factor is usually less than 1. Why? Because it is expected that maximum demand on the power station is generally less than the connected load. So maximum demand will be less than the connected load. Why? Because we are taking maximum demand less means we are generating more from the generating station. We are generating more so that the maximum demand is less. Okay, so for example, if you take maximum demand on the power station is 80 megawatt and the connected load is 100 megawatt. So the demand factor is 0.8. So, okay, so maximum demand what we are expecting is 80 megawatt. So connected load is this. So the knowledge of max demand factors is vital in determining the capacity of the plant equipment. So this can decide the power plant equipment, plant equipment also it will decide. So generally the demand factor is less than 1. So next, average load. So average load is nothing but the average of loads occurring on the power station in a given period of time, even in a day or month or a year. That is known as average load or average demand. Load is nothing but the demand. Okay, so whatever the load is there, that is nothing but the demand. Okay, load is nothing but limit. So how to calculate the average load? The average of load occurring on the power station in a given period of time is known as average load. Simply like that. Average daily average load is equal to number of units generated in a particular day divided by 24 hours. Number of unit, that is units kilowatt hour or megawatt hour generated in a day divided by 24 hours. So generally energy we are mentioning in kilowatt hours. Okay, so monthly average load is nothing but number of units, that is kilowatt hour generated in a month divided by number of hours in a month. So 24 into 30. 24 into 30. That is the number of hours in a month. Next, yearly average load curve. Number of units generated in a year divided by 24 into 365 days. Sorry, 24 into 365 days. That is nothing but 8760 hours. Okay, so 8760 hours. So next, this is of your average load. Next, coming to the load factor. Load factor. So load factor is nothing but ratio of the average load to the maximum demand during a given period is known as load factor. So ratio of the average load to the maximum demand. That is called the load factor, the ratio of the average load to the maximum demand. So what is the load? Generally, the load factor is equal to, so average load into that particular hours, like time, divided by maximum demand into time. So that is nothing but unit generated in hours divided by maximum demand into hours. Load factor may be daily load factor, monthly or annual load factor if the time period considered is a day or a month or a year. The load factor is always less than 1 or 100. Okay, if it is in percentage, it should be less than 100 percentage, because the average load is smaller than the maximum demand. So average load is smaller than the maximum demand. So maximum demand might be of high, and average load is somewhat small. The load factor plays so that it will be coming less than 1. Okay. So, but generally load factor is mentioned in percentage. So what you have to do is you have to go for into 100, into 100, which will give in percentage, like 59 percentage, 60 percentage, 62 percentage, like that it will be there. But it should be less than 1. That is less than 1 or less than 100. 100 percentage. Okay. Next, higher the load factor of the power station, lesser will be the cost. Okay. So if the load factor is higher, lesser will be the cost per unit generated. Okay. Load factor is higher, generally lesser the cost will be generated. Okay, so cost might be going down. Next is diversity factor. So what is meant by diversity factor? Diversity factor is nothing but ratio of sum of individual maximum demand to the maximum demand of the power station. That is known as diversity factor. So ratio of the individual maximum demand to the maximum demand on the power station. So individual maximum demand. So individual maximum demand means in a particular time, what is the maximum demand? Say for example, 4 hours. What is the maximum demand? 20 megawatt plus, next, again, 2 hours, 2 into 10 megawatts plus some 5 hours into 15 megawatt plus, like that you have to go for sum of individual maximum demand divided by maximum demand on the power station. Say maximum demand on the power station is 20 megawatt. So 20 megawatt is taken. So this is sum of individual maximum demand. Okay, sum of individual maximum demand means I said no. So 4 hours, like that, 4 hours, this many megawatt, 20 megawatt plus 5 hours, 10 megawatt plus 8 hours, 5 megawatt plus 4 hours, like that for 24 hours you have to take. A power station supplies load to various types of consumers whose maximum demand generally does not occur at the same time. Okay, so all the maximum demand does not occur at the same time. So no one will on all their loads throughout this world or throughout the country. They might be going to on only, the loads might be of varying from home to home. Okay, so based on our mentality, how we have utilized, like that, we have uh, we have changed. Somebody maybe might be using the like air conditioners, ACs, air coolers, like that. Somebody might be using only ceiling fans. Somebody might be going for some other air coolers. Like that, the say, like pedestal fans. Somebody might be using pedestal fans, like that, it may be varying. Somebody might be on your washing machine in the morning, early morning hours. Somebody might be on your washing machine at the late night hours after 10 o'clock, like that. Somebody might be going for on the washing machine at in the noon hours, like 12 o'clock to 1 o'clock, like that. So it may be varying from one house to another house. That is one consumer to another consumers. Nobody can go for the same timetable. Okay, this time we have to on the washing machine, like that. Nobody goes for this. So like that, it may be varying. It may be varying at different times. Load may, therefore the maximum demand on the power station is always less than the some of the individual maximum demand on the consumers. So like individual maximum demand of the consumers, one house it may be if you take like a particular hours for 4 hours from morning and like 9 o'clock to 12 noon. In my home it might be of somewhat lesser kilowatt hour. Okay, point 0.5 like that. Somebody owns like one, the somebody owns two, three, like that it may be. So that we are adding sum of individual maximum demand divided by maximum demand of power station. So obviously diversity factor will be greater than 1. So if it is there, it will be generally greater than 1. So diversity factor, lesser the diversity factor, cost of the is the greater the diversity factor, lesser is the cost of the power. Okay, so if the diversity factor is greater, then the cost of the generation will be less. Okay, if the diversity factor is lesser, okay, if maximum demand is greater than the sum of the individual maximum demand is, that is in a reverse case I'm telling, in that scenario it will be less than 1. It will be less than 1. So the cost of the generation will be goes higher. If the cost of the generation goes higher means it will be reflecting on your tariff. Okay, definitely it might be reflecting on your tariff. So tariff to the consumers will be increasing like anything.